And good morning, everyone. So I'm Sanjana Hussain, and I'm a PhD student working with Professor Habib. Unfortunately, Dr. Habib couldn't be here today due to some last-minute emergency, so I'll be presenting on his behalf. As Dr. Brendan mentioned, our presentation today is about the use of smart card data to model transit demand. More specifically, how we can make use of transit smart card transactions for transit demand analysis. So I'll start off with some opening remarks and highlight some data gaps in the smart card transactions from demand modeling perspective. Then I'll present a data fusion type methodology that can be used to fill in these gaps. After that, I'll discuss some potential applications and share the findings of a project we did on this topic. So to start off, I think we all agree that reliable and up-to-date origin destination information is vital for transit demand analysis. But this type of up-to-date information is quite challenging to obtain, especially because OD surveys are costly and they are time-consuming to implement as well. Smart card data can provide a viable solution to this challenge because this data is continuously collected and can be analyzed to obtain rich spatial and temporal travel information. The data can be aggregated by different temporal units, say like on a daily, weekly, or even annual basis, to provide accurate picture of transit demand and its variations, like say seasonal variations or weekday versus weekend variations and so on. So this data has the potential to provide high quality and up-to-date OD matrices of the transit network. However, the issue is that it's not sufficient on its own. This is because the data is at the stop or station level. So we can understand what's happening stop to stop, but beyond that, we don't have any information. So like we don't know how, what the actual origin and destination of the trips, of the transit trips are. So like we don't know where the trips actually started and ended. So we miss the access and egress links of the trips when looking at only smart card data. And even say for flat fare systems where we just tap on the vehicle and necessarily don't tap off, and also there might be barrier-free transfers between vehicles. So in those cases, we might not have information on the egress stop as well. So like we have to rely on heuristics and algorithms to identify the tap off locations, which has been done frequently in the literature. Also in the smart card data, we don't have any information on the socioeconomic profile of the users beyond maybe whether the student is minor or a student based on the registration type of the card. Now, these missing pieces of information, I'm sorry. So these missing pieces of information is vital for demand analysis, definitely. So there might be a tendency to use plain rules, like assuming the zones of access or egress stops as the origin and destination zones of the trips. But in many cases, these kind of rule-based imputation of OD can be misleading and wrong, especially if there is a significant portion of park and ride and kiss and ride trips, which is quite common within the GTA. So we might actually underestimate the spatial dispersion of the transit demand, which is definitely problematic. So in our research project, we analyzed the feasibility of supplementing the smart card data by model-based inference of the missing information. We wanted to test if the smart card data can be expanded by fusing it with companion data sets like customer satisfaction surveys or even regional household travel surveys. So the basic idea here is to use transit trip details from the companion data set to model the trip details that are missing in the smart card data, like the trip origin and destination locations, access and egress travel modes, maybe trip purpose, or the socioeconomic profile of the users. So like one potential application of this method can be using our Presto card data to complement the transportation tomorrow survey data. So in the TTS data, we have all the details of the transit trip of a subset of the population. Whereas in the Presto data, we have the tap on locations, and say for Go Transit transactions, we also have the tap off locations of all transit trips given, or like almost all transit trips, given that 100% rollout and adoption of the card. But we have some missing information in the Presto data. So we can fuse in these two sources of information and infer the missing information, which would give us a more detailed representation of transit demand than the TTS, both spatially and temporally. So similarly, there can be another potential application. Say if we have customer satisfaction survey data, which contains the socioeconomic profile of the users, we can fuse that information with the Presto data to obtain demand distribution by user profile and more detailed user behavior. So we empirically tested our proposed method to infer the origin and destination of the smart card trips. So the first potential application that I talked about. For this, we used Presto transactions from October 2016 and the 2016 TTS transit data. So first, we modeled the origin and destination zones of the TTS trips in terms of zonal attributes like the land use entropy, distance of the zone from a particular station, its population density, and so on. And also the access and egress station characteristics like their parking capacities or passenger pickup and drop-off facilities, whether the station provides connections with regional transit, and so on. Next, we processed the Presto card data to infer the alighting stops and recreate the entire trip by linking trip legs and identifying transfers. Then we applied the estimated model to the Presto trips to infer the origin and destination zones of those trips. So we tested this method for both tap on only and tap on and off systems, and for networks with substantial shares of both automobile access and walk access or egress. And we found that the method can successfully capture the spatial distribution of trip OD at the traffic analysis zone level. So this kind of proved that smart card data can provide up-to-date and almost continuous transit demand levels and distributions, but it needs to be incorporated or fused with appropriate companion data sources. Also, it is important to use a model-based fusion method rather than rules and heuristics to make sure the results are realistic. Once the fusion framework is developed, we can set up, say, a data extraction system of some sort which would have the estimated models working at the back end and the output or the output of the inferred OD information would be shown in the front end, so that the entire process is a bit more user-friendly and time-sensitive. And then we can update this framework every once in a while whenever a new set of estimation data becomes available. So in this way, we can obtain more up-to-date OD information and thus have more current estimate of transit demand using the smart car data and some data analytics. So this brings me to the end of my presentation. I just kept it very high level to squeeze it within the time that we have. I would like to acknowledge the funding partners of the study, especially Metrolinx, who provided the PrestoCard data for the empirical investigation. So thank you very much, and I would be happy to answer any question.
Thank you very much, Sanjana. That was very interesting, because it's been a question of how do you get sociodemographic information. You can't, because of privacy rules, you really can't get it from the smart card data directly. Quick question. I don't see any in the chat, so I'll throw out one. Both the TTS and customer satisfaction surveys tend to be snapshots. I mean, they're one-time snapshots. What's your feeling about whether your approach could work with travel diaries, as where there's a continuous, survey of perceptions and reactions? Granted, it's specifically of transit customers. Do you have any thoughts about that?
So I guess you are referring to the fact if we have a continuous source of information coming in for the, like that would be the most ideal case, because the framework that we are conceptualizing right now, it's based on, say, the estimation data, which we have every, say for TTS, every 5 years. So that's kind of like, that's one aspect which we are not being able to improve, other than the fact that the transit, the smart card data, the Presto data that's coming in, that's more up to date. And so the parameters that we are relying our inference on, while those might be lagging a bit behind, but our the inference results are better than, say, like 5-year-old ODs. But definitely, if we have a more up-to-date and continuous source of information, we can have an algorithm working continuously to update the parameters, and that would essentially give us more up-to-date data. Like that would be the most ideal case.
Yeah, great.